Hello, can
Hello?
you hear me?
Yeah.
Hi, nice to meet you. Yeah, I see you in the code bank. Can you share your screen so we can record this over the Zoom?
Can you see it?
Yes, cool. Then jump into coding for 40 minutes and spend the rest of the time for feedback plus questions and solutions. Okay, then let me choose a question that will be closer to your experience tomorrow.
Yeah.
Meaning, cool. Let me paste you this question. We're using Python 3 today.
Oh, yeah.
Okay, so yep. Okay, yeah. Go ahead. If you have any question, please let me know.
Okay, thanks. Let's see. Unsorted array of integers find the length of the longest consecutive. So I think like a way to solve it. First of all, I think let me see if there's any assumptions or like anything like that we can have, or like any of the corner case that we want to discuss. I think it's quite clear. I mean, yeah. So like, I think one idea I think of is that like when we can iterate through the array, right? And first of all, we can store this array in like a hash set or like a hash map, like because the order doesn't matter. And like then like when, for example, like if we for the first one, right? Like if we iterate through any like all of the elements in the array. And for example, like we first see 4, right? We only look for the number higher than 4. So like, for example, if we see 4 here and we search if there's 5 there. So if there's not, then like we just store 1 there. I mean, same for 100 and 200, of course. But then like when we see 1, right, we look for if there's 2 there. So if there's 2, and then we look for 3 and keep doing that. And after that, like we know that like after visit 3, we know like 3 only have 1 number larger than that, and 2 have 2, and then like 1 we know there are 3 numbers larger than this, or continuous from 1. So we know 1, we say 4 here. So then like we don't need to revisit like the number we already visited. So then next time when we go to 3, right? So we don't need to still visit 3 because we already visited when we finding like the consecutive number starting from 1. So under this situation, like we only need O(n) time to iterate through the list and find out like what's the longest consecutive elements in a row. Yeah.
Oops, my question muted. What's the total time complexity and total space complexity?
Say like if we have n numbers, the time complexity will be O(n), and the space complexity is also O(n) because we need to store like how many number we have starting from this one, and so yeah.
Okay, cool. Sounds like a good plan. Yeah, why don't you start writing some code below line 18?
Okay.
Yeah.
So just call numbers. If the input is an empty array, what do you want me to return, 0 or -1?
So if you have nothing, what's the longest consecutive sequence you can make? The length of consecutive sequence.
Oh, then it's just 0.
0. Yep.
Yeah. So we can have a dictionary because it's a hash set. We can visit the key in O(n), and also we can store the length with this dictionary. So the key will be number. Value will be count. So then we iterate through the numbers, and also we can have the else. let's see. How do we see if number plus one in let's see. Stored. Yeah, let me think. Maybe I was thinking like, how do we just can store that quickly?
Okay.
We can have a helper. Else. Let's see. So sorry. Wait. If number plus one in also. Well, I'm just trying to think how to write it, more elegant. I don't want to make it very messy.
So try to make a running code, and you can later optimize it later.
Okay.
Our goal here is coming up with a working solution upfront.
Yeah.
And yeah.
Okay.
Because doing the writing a code and also optimize it at the same time will be a little slow.
Yeah, make it more complicated. Okay. So yeah, so then like I can just first focus on this one. If number plus one in contradiction. Oh, sorry. So then let's just make it regular dictionary since I already defined the so then I have accounting. Else if so Let's see. Wait. We need to update the dictionary. Yeah, I think that's it. Yeah. Do you want me to go over the logic here?
Yeah.
Okay. So I mean, like, so first of all, I mean, like, if we have an empty array that we know the like max length we can get is just 0, so we return 0, and then like we have a dictionary which will count like the how many number are consecutive starting with a current number, and we have a helper function which is basically like we keep searching for like how many number it can go. And like while with this like updating process or like counting process, we also update the child of this. So basically, it's like a recursive function that if the number is not in the count dictionary, which means like we keep adding this number by 1, right? So whenever we reach a boundary that we know there is no number after this, there is no this number is not in the dictionary. So yeah, we just return 0, and then like if we have like this number greater than or equals to 1, then we know we have already visited this number in the past runs. So we can just return like this number within the dictionary. And otherwise, you know, we can just keep like we can just call this function and on a number plus 1, and to find out like what's a consecutive number starting with this number plus 1, and we add that 1 on that number, so we know this was a consecutive number starting with the current number, and we can return this as a total like length starting from this number, and then we just iterate through all the numbers, and then like we just find out what's the max amount, max number or max length, you know, among those return it.
Okay. Yeah. Can you do some examples?
Oh yeah. I mean, like, same for the first one, right? For the first input, I mean, like, we first have a count dictionary with a key of like, so basically this defined part that we have a key of 104, 200, 132 as a key, and the value will be 0 for them, and we start with 100, right? So like for this loop, we first look at 100, and then like and we run the helper function on 100, and since like first of all, I mean like 100 is in the count dictionary, so we pass this condition, and like the count of like 100 is 0 currently, so we pass this condition, and then like we see if 101 is in the dictionary, so it's not, so or say like we run helper on the 101, and then like if it's not in the dictionary, so this helper function will return 0. So we have like update the count dictionary of 100 to 1, and then we return 1, like we update the dictionary and return 1 here. So output was like counting max of output and 1. So that's the example of like number like 100. But for example, if we visit a number like this 1, that we know that there's number larger than that, right? So we keep running the helper function that because we start with this 1, and since we haven't visited this 1, so we pass first 2 conditions, and then like we run the helper function on 1 plus like on 2, and then like on 3, and until like we run this helper function on 4. So we update the like helper function of 4, like we return 1. So like the for will be same as what happened to 100, right? So then like we update same story, and then like we update 3 based on the fourth number. So we have like 2 for 3 and 3 for 2, and then finally we have 4 for 1. So we update this number, and when we go to number 3, like we run this number go to 3, and we run the helper function on 3 since it already been visited. So we have this count greater or equals to 1. So we will pass, or like we will just return like whatever it has in the dictionary. So we don't need to, go through all the following numbers again. So that's the reason why we have total time O(n).
Yeah, why don't you run some test case calling this function and see if it returns the expected output.
Okay. You mean execute this function, right?
Yeah, call the function using a print statement, and let's see what it prints out.
So yeah, you see like 4 as output. So we run the second one. Oh, sorry, this one. So I have 9 as output. Sorry. So I think it passed these 2 test cases. Yeah.
Okay. Can you try to test another test case?
Oh, okay. So you want me to try some specific? I mean, let's see. Okay. What other?
Create your own test case.
Yeah.
Let's see if that works too.
Something like this, I guess. So it's 1, and another one I would like to try is like our same number. Yeah, I think yeah, that's test cases I want to try here.
What other test case?
Oh, you want me to try some more?
Yeah, because I think there could be some other case that could. What about 5, 4, 3, 2, 1?
Oh yeah.
Or 1, 2, 3, 4, 5.
Same. I mean, like you want me to run this, right?
Yep. Okay. What about 1, 2, 3, 4, 5?
Yeah. Yeah.
Okay. Cool. What about? Let's see. So you're looking up the number.
Yeah.
Number. Okay. Okay. What if it's like 1, 5, 3, 4, 2. Let's see. Okay.
Yeah. It's just like you don't trust this. Is there anything that you can just give me some constructive?
Okay,
Yeah, like,
what about negative numbers?
Oh yeah. I mean, I'm just curious. I mean, is it because that like you think like during interview it's better for me, just have like all those complex different combination of test cases, or?
I'm just curious.
Okay. Yeah. Yeah, I heard from some other interviewers it's better, I can provide some test cases to run. Yeah, so here is 3 because 0 and -1. Oh, but we have 2, 3, so maybe translate to a much larger. So it's supposed to return 3, right? Because we have -1, -2, and 0. Let's see.
Okay.
So it's
just a second. Give me a second. Okay, got it. What can you tell me, like, what the worst time complexity could be?
It's still O(n) because that when you have like for example, like the worst you could have maybe is 5, 4, 3, 2, 1 or something like that, right? But the thing is that like when you sorry, the words will be 1, 2, 3, 4, 5, I think. But like when you have, I mean, it's same words because it's the same. But because like when you visit the 1, right, you already visited the 2, 3, 4, 5, so like you don't need to visit them again. But when you do like 1, 2, 5, 4, 3, 2, 1, like although like when you do like the 4, you need to visit 5 once. And when you visit 3, you need to visit 4 once. But still ON, right? You don't need to like revisit the same number twice. So I mean, like yeah, that's it. Yeah.
All right, let's do another question. Let's see. Find it. And let me list this one. Can you scroll down?
Yeah. Yes. In a sorted array of size and find the majority element. The majority elements element that appear modern. Oh, that's an interesting question. I mean, like, I mean, a quick question. I mean, like, if there are 2 of the number appear more than like n over 4 times, we just return the one with the largest like element number, right? I mean, largest count, right?
Let's first assume there will be only one answer.
Okay.
But if you have multiple answers, let's try to find the smaller number.
Okay. No problem.
Yeah.
I mean, first, very naive approach that is just like we have a counter or like, we count. I will keep a dictionary, like to count how many times this number will appear. And then like finally that we just return the number with the largest count, and we iterate through the keys from the small to largest, and then like we find out whatever like number appear the most. But this will take ON, and I'm pretty sure like there's a log n solution, because like otherwise, I mean the n over 4 is very suspicious here. So so yeah.
Yeah. Let's do better than linear time. So I'm looking for since it's sorted, let's do better than linear.
Yeah. So yeah, I believe there is a log n solution. Let's see. So let me think about it a little bit. I mean, like another very naive approach I think of, which will take log n time, but I'm pretty sure it's not the best solution, is that like we can pick a point, like a point at like from like n over 8, and then like 2n over 8 to 8n over 8, which is like, so basically we select 8 points in the array, and we just see like whatever number appear more than 2 times. And then like we have a list of those, and then we can use some other, like say like binary search or whatever, to find out like what's the left and the right end of those numbers, and then we'll have a count of those, and we just compare which one is which one has is the smallest number with the longest or appear the most. and we return that number. So this is a log-n approach, but it's not very elegant. So I think there will be better one.
Does it work?
You see, like my idea is that like so we pick the number at n/8 to n/8, which is n/4 but anyway, right? I mean, I think it will work, but like we can discuss 3n/8.
What's that n/8? What's n/8 means?
Oh, you just the index of the number, right? So we can get the integer part of this, but basically like, so we have an array that we can, just look for the number at specific index. And if there's a 4, like n/4 times appear there, then which means
that it appeared n/4 times in the index element.
Sorry, what's that?
How do you know the number you access from that index appears more than?
Because it's sorted, right? So it appears continuously. So if, for example, if you see those two like index with the same number, then you know that it's possible this number appear more than 4. Or say like if a number appear more than n/4 times, it has to appear in 2 of those, right?
Why is it? Why do you divide? Why is the base 8? n/8, 2n/8, 3n/8, 4n/8. Why do you have 8 there?
Oh, because like 8 is like 2 times 4, right? Because
why do you do 2 times 4?
Because like if a number like have length more than like 4, like n/4, means like if we draw like a bar, which then like it must be like appear like 1/4 of it, right? So if we pick 2 points, I mean like because if we pick half of the length of this, I mean like it's guaranteed that we at least it appear twice, right? Like in this 1/4 length, right? So the best chance that we will have 3 points, but like this kind of tricky because you need to get the integer part of it, so there might be a mistake. But theoretically, if n is large enough, that's a way to do it.
But if you do 1/8, there could be multiple answers.
Yeah. So then like you do because even there are multiple number, you limit the number to 8, right? So the worst case is 4. The worst case you have 4 of them. So then like
length is 11. Can you do that example? So 0, 1, 2, 3, 4, 1, 2, 3, 4, 8, 9, 10, 11. So n equals 11. Can you do that?
Yeah, I mean when n is small, it's tricky because when you have n divided by 8, it's I mean like or 2n divided by 8, like those are very close, right? Like you barely have 8 points here. So I mean like it works better when n is large, So you might fall like 2 of those. Yeah, I mean we can. I mean if this is not a good approach, we can just skip it, like just for time saving. But this is just my thought, like at the beginning.
Okay.
Do you want to go ahead with this, or let me try something else?
I mean it doesn't work for n equals 11, so
yeah.
I don't know whether.
Okay, so we can skip. No, I think it worked, but like but I think it's better for us to start with some other approach. Yeah. What do you think? Agree?
No, it's your choice. Yeah.
Okay. Yeah. Let's try with. Sorry. Yeah. Let's try with some other approach. So can we do binary? Because I mean, like my thought would be like so since it's very suspicious for log-n, it's the ultimate solution. So I mean, like it's probably either we can do it with a divide and conquer, or like a binary search, I guess. So I guess just try to find like which one to use.
I think so far, I think this is the closest like approach that you seems to be reasonable, but I'm just curious if you just look at 1/8 for every index.
Yeah. So we will
would return the answer. So
yeah, so we will have like probably 8 index, right? Probably like with that approach then like we will have like say.
So let's say we have like the length is somewhat like this, and you say somewhere here is 1/4 And this is what, 2 over n?
Sorry, it's 2n over 8, right? What?
No, I'm dividing in 4 different.
Oh, yeah. Okay. Makes sense. Yeah.
This is 2.
Yeah, I think like you find some point which is very suspicious, and then you can use a binary search to find the left and right, and you can determine. But
so it's n over 4.
Yeah. 2. And
This is n.
Yeah.
But not, you're now going to one more level here, right? N over 8.
Yeah.
Is it 2 over 8? Is it?
Yeah. It will be 3 over 8 here, right? Because it's middle.
Oh, you will have another one here.
Yeah. So we
Another here.
Yeah.
What? Can you fill it out later?
Yeah. But it's not, like, don't worry about the detail. Yeah. So 5. Yeah, but like, please make sure before the end of interview, let me know what's the correct way to do this. Thanks. Yeah, I'm very curious. But I mean, for this approach, I mean, it's more like, the.
So you're saying you're looking at these 2?
Yeah, we look at like each of these continue to, right? If these 2 return the same number, right? If this is we have a suspicious like list, right? Like whatever could be the final answer. So at most we can.
It could. Wait. So if you say at this point the number is 3, and at this point number is 3.
Yeah. So 3 is one of the possible answer for the final answer.
No, it could be. What if like from index n over 8 to index n over 4 is all 3. Let's say that.
Yeah.
That frequency is it's only n over 8 occurrence.
Yeah, you're right. Yeah. So that's why I said suspicious. But because like
which is not over 4.
Yeah, I know. But like the reason why I do it this way is if you split only like n over 4, you're not guaranteed to have it, because for example, what if you have somewhere at the somewhere appear here, you will only appear once, right? So this n over 4. So if you have here, of course you will appear twice. But if you what if you have
So the point is, if you have a fixed index, sometimes you can catch it luckily. Sometimes you cannot catch it luckily. So
n over 8 is guaranteed, because it's like it's the pigeon and cage problem, right? Because the length you keep is half of the length you're searching for. So at least like one of this beginning and ending will fall within this range. So that's the reason why I go with n over 8 instead of n over 4. So at least 2 of them, if there's an answer, at least 2 of them will show the same answer. At most, you only have 7 of these numbers, suspicious numbers. You even do like even you have a log n to find the left and right end, you just do it 7 times, it's still like a log n solution. That's my point.
If you have a number from here to here, the same number.
Yeah.
This is only occurring n over 8 times.
I agree. Yeah.
But you're saying this could be the answer?
I mean, like at most we'll have 7 number like this, right?
7 numbers, but this is not.
I know, but we can compare this 7 number, which one has the most frequency and the smallest key, right?
Even though this is,
because 7 is a constant, so that's the reason why I don't care like how many more I have within this 7 number.
Where do you get the 7 from?
So each of like, if we have both appear here and here, right? 1.
Yeah.
1. And so we have 7. So 7 is a constant. So even we do log n to find the left end, log n to find right end, it's still like 7 times log n, like or 14 times.
Okay. What if Okay, so you're doing that. Oh, then time complexity-wise, then is log n, isn't it? What you
Yeah, it's still log n, and you're guaranteed to find that because that like because we pick n over 8, right? So like even the worst case, like we have like 2 of the range fall within the n over 4 range. So we are guaranteed to find 2 points. So if it exists, a guarantee to have 2 continuing points in that, but it's not guaranteed that's the answer, right? It still can be, as you said, it can be less than n over 4 times. But still, at most we have 7 suspicious. We just need to find which one is the right murder, like right answer. Yeah.
Okay. So the time complexity and 7 times log n.
Log n, yeah, because we need log n to find the left and the right end. So just using binary search.
What are you searching for?
Searching for like so for example, if 3 appear twice, right? So we search 3 within this list. So what's the left end of the index, or what's the right end of index? We use the right end minus left end plus 1, which is how many appear.
Okay.
Yeah. So it's a log n to find the number up here. So we have like these 7 numbers, at most 7 numbers, and how many times they appear. We saw this number from small to large. It's still like 0.7 log 7. So anyway, and then like yeah.
Cool. Yeah, I think our time's up. So let's stop here. Yeah.
Yeah, but I'm really curious. Like, what's a better answer? For this one, I'm super curious. Like, I know my approach is bad, but yeah,
we'll get there. We'll get there.
Yeah.
I'll tell you the answer at the end. So, how do you feel this mock went overall? Tell me your thoughts or self-reflections. Where you think you did well? Where do you think you could have done better? Can you share your thoughts, and I'll tell you my thoughts.
Okay. So what I did not good is that for example, like for something that for first problem, I think I'm not familiar, or like I don't really like recursion problems. So whenever I see recursion, I feel nervous. So which make me struggle there. But like it's not like I can solve it. I just don't feel confident about that. So but I think I should be like more patient, and whenever I see a problem, because I feel like whenever I see a recursion problem, I kind of scare myself, And second is that for the second problem, I think what I can do better is definitely I need to explain myself better to you, because obviously, I didn't make it very clear to you at the beginning. So like I spent a lot of time on explaining this. But I think if I can improve my communication skill, and I can describe my idea better, I think it will save me some time. So
yeah, I think you know yourself very well. I think your coding speed is really quick, and your thinking process is really quick. I'm guessing that you are doing well with LeetCode and practicing problems daily. So I can sense that. So you have really quick idea of what to do. So first question, you had a good idea immediately using a hash set, helping that to reduce the time complexity down to linear time. And that is correct. Many people, first question, use sorting to sort and linear scan, which is brute force. And of course, that's not the level, that's not what you're looking for. You need a linear time using the data structure to lower the time. So your approach is working. But there's another way to solve this problem. Let me share you that. Yeah, how I solved using this question is you're looking only up, right?
Yeah.
And you're building the dictionary as you traverse each number.
Yeah.
But my approach is think about, we have a black box. It's black box. We have a box in front of you. You have all the numbers. You copy all the numbers in the black box initially. So black box has everything in it.
Yeah.
Now we iterate each number that you have. So if you have number 100, what you do is try to find the longest number you can stretch left and right centered in that number we have. So 100, we try to look 99 in the black box. If there's 99, we pull it out, attach it, and stretch as much as left you can go. Small number. If there's no number, stop it. Now we go up. Look at the right side. Is there 101? If there is, pull it out, attach it. Try to make it long left and right at centered in that number. 100 has nothing. So we skip to next number 4. We look down. Is there 3 in the box? Yes, we pull it out. Is there 2 in the box? Pull it out. Is there 1 in the box? Pull it out. And now 0 is not in the box anymore. We look at the number up bigger than 4. 5. Is there 5? No. So 4 can stretch 1, 2, 3, 4, the longest. Now the boxes have, think about that. We access it in all of one time, pull it out.
Yeah.
Now the next number is 200. 199 is not there. 201 is not there. So the longest number we can for centered at 200 is just length of 1. That's number itself. Next number is 1. Look at the number down. 0 is there? No. Is there 2 in it? No, because 4 already pulled the number out when it was processing. So it's skipped. Number 3 and number 2 is always the same thing. Up and down, there's nothing in the box. So you cannot form the longest. So this is how it works. Using a hash set, copy all the numbers. Every number we look at in the map, in the input, we stretch up and down.
Yeah,
this is going to be linear time complexity and linear space. Space is the box, the hash set. Linear time is we are accessing the number, but we're not duplicating the access because we are moving the number out of the hash set. So that's how I did it. And let me show you the code. Yeah, give a minute to read the code. Yeah. So we have set, and then we have number left and right. Go left, 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 left until you as far as you can. Go right, 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 right as far as you can, and make that maximum length every time. So this looks like a for loop and a while loop. So it might look like an n square solution, but it's not because you're removing the number. So this is one solution, but yours is also working. So there's another. Second question. The first question is in the leak code. Second question, I don't think it's in the leak code yet. So this is, I think it was from the phone interview with Facebook. I think I found it a long time ago. The interesting thing is your approach could work, and that could be one of the answer. But my approach is 4 times log n.
Okay.
Yours is 4. I'm looking only index 0, index n over 4, or 25th percentile, 50th percentile, and 75th percentile. I'm looking at 4 points. So what do I do is I go to index 0. There could be a number, right?
Yeah.
I try to find, as you said, what is the number that's appearing in the same number in the input.
Yeah.
Just a second. Let me shoot. I think it's easier to shush since you're running out of time. Can you take a look at this code?
Oh, yeah. Oh, it's very short. Nice.
Yeah, very short. So we're looking at 4 index 0, 25th, 50th percentile, 75th percentile. We'll have a number in that index. Now I want to find the starting index that the number is starting at using a binary search.
Yeah.
So this will give you the starting index of that number that we just looked at.
Yeah.
Now we compare that number position plus n over 4. If they're same, we found it. If we didn't find it, we go to the next index, n over 4, 25th percentile, and find the number, find the starting number of that number in the array, and find that index plus n over 4. If that's equal, all numbers in the middle will be the same number. So this will return it. So you asked a good question about what if there's multiples? We'll return the smallest. So we'll start from index 0 to go up. So anytime you find your number, we finish it. Return the number.
Oh, yeah. I mean,
so yours is more fine. You're looking at 7 points, but theoretically, we can just look at four different index.
Yeah.
Look at the number, do a finite search, get the starting index, and compare the number starting index plus n over 4. If they're equal, all the numbers will be exactly the same, and that will be more than n over 4. So we find the number. That's quarterly majority number. So this question is pretty tough, but I think you got very close. So I think you have a good idea, and you have really well prepared. So good job. Yeah, this is the very short answer.
Yeah,
I think overall, one thing I would suggest you to do is just draw something as much as you can using the code template.
Yeah.
Because we want to visualize. While you're visualizing this and tell me your process, maybe you could have some aha moments while you're explaining. Because sometimes you learn something new insight while you're teaching others or telling others your approach. So let's do some explanation by drawing something or doing more test case. That will help you get there because you have a good direction. You have a good sense of how to tackle the problem because you always challenge yourself. You have this good brute force, but you know that there's a better way. You have the sense. So keep pushing that. Just expose yourself to many other code problems as much as possible. And for tomorrow, I think just have to so if you have solved any questions using sorted dictionary, I would repeat it. So it's like a problem that uses the hash map, but in a tree map fashion to find a ceiling key or floor key and using that. So one example is like skyline problem. Do you know that?
Yeah, I know. Yeah, that's a tough one.
Tough one, right? But using tree map is like one of the things I always see others getting because that's really tough, like topological sort. People don't get it. Most of the people don't get it, but that's a good question that can filter out candidates who can pass the offer. But anyways, do you have any other questions for me?
Yeah, thanks. Yeah.
One last thing is if you know the question, let's say you got a question and you just know it. Let's say you got a question tomorrow that I gave you the first question.
Yeah.
Do not jump into the optimal solution so quickly.
Okay.
I know you are trying to push yourself to do the optimal immediately, solve the question very quickly. But if you do that, number one, they might know that you already know the question. You might fall into some trap that you solve. You jump into optimal so quickly, they might twist the question to you. So my advice is, even though you know the question, even though you know how to solve it, start from brute force. Provide a brute force solution. Slowly optimize time complexity or space complexity, step by step. Don't just jump into optimal. I know this question and just jump into it.
Yeah, thanks, man. Yeah, really appreciate it. Super helpful. Yeah, thanks, man.
Bye.
Yeah, bye.